We would like to welcome Mohanpriya and Hema. Latha. Mohanpriya is a senior associate at Cognizant and has around 7 years of experience in performance testing and operational acceptance testing. Hema is working as a performance test analyst at Cognizant and has more than 4.5 years as a performance test engineering experience. Mohanpriya and Hema would be speaking on the topic Test Your Infra Resilience in a Boring Way or in the Best Way. To know more about them and to see their video interview, please check on the following links. Over to you all.
So, ma'am, I'll stop sharing and you guys can continue. Stage is
Sure.
all yours.
Sure, sure. Thank you.
I started sharing. Please let me know if it is visible. Yeah.
Yeah, able to see him. Yeah.
Yeah. Fine.
Yes.
So
So, good evening,
continue.
everyone. We are here to present about the topic like test your infra resilience in a boring way or in the best way, right? And our agenda is to cover about what is resiliency testing and what is the need of the resiliency testing, and then we are planning to cover how resiliency testing happened in a real background, and then we are also covering high availability versus fault tolerance, a kind of resiliency testing that we used to do, followed by the traditional approach that we used to follow for resiliency testing, and then our own approach that we are planning to apply, and then followed by a demo. We'll be also covering best practices as well as the benefits. So yeah, hopefully, thank you, Hema. Like, can you take it from here?
Yeah, sure. Myself, Hemalatam, we believe that our session will nurture the viewers with various concepts like chaos engineering, resiliency, and high availability, and etc. So let's buckle up and get into the session. So our topic is test your infra resilience in a boring way or in the best way. Before jumping straightly into the topic, let us revisit the origin of this resilience testing. So resilience testing is a kind of operational acceptance testing. Again, that comes under the non-functional testing. We all know what is non-functional testing is, right? So non-functional testing is nothing but that assesses the application properties that contribute to the end user's experience. So say for an example, we will test what if the server or the services goes down during the order creation by the users, or what if what will happen to the logged in users during the disruption. So such scenarios and all we will validate just to ensure that the solution or the application is resilient enough to withstand the
I think Hema, are you there? I'm not able to hear. Hello?
Let me check with her. Give me a
Sh-
minute.
Sure, sure, sure. Guys, just give us a minute. In the meanwhile, we are connecting with the speakers. Hema, are you there?
Am I audible? Hello.
Yes, Hema, I think we can hear
Yes,
you.
Hema.
Sorry, sorry.
No, no, no
What
worries. I
happened?
think all this things happen in an online conference. I think we are good. You can continue.
Yeah, yeah, okay. So that is the thing, we ensure that the application is operationally fit to go live. So that is the main aspect of this operational acceptance testing. So coming to the resilience, let us go with an example. Clients coming up requirements stating, hey, my application has to be accessible by all the users, even in case of the disasters or the disruptions. And also, I should not lose my company's reputation. And also, the solution should be cost efficient. So, in that way, to satisfy those requirements of the clients, we suggest to test the resilience of the developed solution. So the testing is right. It is you like system can regain to its original state. That is what we are mainly testing in our
Hello, Hema. Can you hear me?
Yeah, we couldn't hear you, Hema.
Guys, Hema and Mohanpriya. I hope I'm audible. Sumit this side.
Yes.
I think there is some bad network right now, or maybe a load. So I'm just suggesting, like, maybe both of you can turn off your video. Might be it will bring some bandwidth, and it will be good because your
Oh,
audio
Yeah, yeah,
and
sure.
video is checking. Thank you.
yeah, or otherwise, at
Sure,
least
sure.
Mohan Priya, in the meanwhile, can you continue with the session while Hema resolves the issue at her end?
Yes, right.
Yeah.
Yeah. So for now, we are going to talk about the need for resiliency testing, right? So, like when it comes to like whatever it may be, the service provider or whatever may be a solution or a system, it can be. So even though it is built with a very high-end software or a well-designed one, we cannot ensure that the system can run it can be available or it can be 100% resilient. We cannot confirm that, right? So to prove that, we need to test certain cases if what if a service can be down or what if service cannot be there can be a network interruption or a huge amount of users may come in to a system. So there are so many cases where there and then we need to verify like how well the system responds to that, even if some failures, or how immediately it is recovering from the failures to its normal steady state behavior, right? So to ensure that, we need to go for a resiliency testing. So to open like to explain it in a clear way, we have a real time experience, our case studies. We have a lot of resiliency case studies, right? So for chaos engineering, yeah, you would be aware that it is evolved from Netflix, right? So they have developed a concept called chaos monkey, right, solution to ensure that the system is 100% resilient. What they used to do is they used to experiment certain negative scenarios where they would like to create so many disruption, and then they'll easily develop how this can be handled, right? So instead of surprises, we should try to experiment those scenarios and then try to find the remedies from the results, and then either they can be trying to do it automatically or we can find a solution to it by using any set of tools. So that is how it evolved. Even for a there are certain cases, and a new web series has been launched from Netflix, or we are also seeing matches by using Hotstar. A huge amount of users will be logging into the system, right? But still the streaming quality or the slowness will be tackled well, and then it is auto scaling well, and then so we are able to get the complete services without any disruption. So to resolve those mitigations that we get, in case of interruption or network disruption or service unavailability or server unavailability, like so many cases were there. To avoid those things, so we used to go for the need for resiliency testings. So come to the second point. Can you move on to the no, the previous slide, please? So then we'll be having the like a huge amount of microservices built in your distributed system, right? So at that time there will be a lot of services, microservices will be built in to perform your system well. So in that case, it's really really hard to identify which services may go down, right? So at that time like you should have an alternate option, so that a system can perform, means like your business will not be interrupted, and the additional the alternate services can pick your queries, and then it can automatically move on to your actual business work. And then the third point is that you will be having a certain SLAs, means like a predefined SLAs will be provided by the companies, and we need to verify that whether it will be coming under which high availability category. It can be a 5.9 availability or 4.9 availability. So before that we should know like what is high availability. High availability is nothing but which is the uptime of your service environment, which means like considering a certain downtime would be accepted, and then like with like that there could not be any interruption in that, right? So here 5.9 availability and 4.9 availability we are talking about, which means like 99.99 percentage availability should be expected from that particular cloud provider, right? So if you want to ensure that 100 percentage, which means that there should not be any downtime, but which is not possible, we can still handle it with a very less number of downtime or outages in your system for any of the issues or any negative or failure condition. So that is the reason we used to have certain SLAs for that availability criteria. And then the fourth practice that fourth important thing is like for every resiliency testing we should have a best practices, right? So before proceeding a certain resiliency kiosk experiment, you should have what and all things or requirements which has to be in place that you have to follow, followed by you should have a respective remedy for each and every failures, so that you can avoid those in your future like solution, like if it even if it case occurs in your system. So we'll move on to the high availability and then the fault tolerance.
So yeah. So high availability, as Priya already mentioned, right? It is like ability of the system to continuously operate without failing for a designated period of time. Which means for the system will be down for the accepted SLA. Like there will be some agreed SLA of downtime for which the system will be down, right? And another thing is that the fault tolerance. Fault tolerance is nothing but the ability of the system to continuously available even in the case of the disasters. So why we are looking into these the principles of this high availability and fault tolerance? Because these are the important factors while measuring the resilience of your infrastructure or the system. Right? If you can see in this diagram, the first site is active and the second one is passive. If something goes down, right, there is some acceptable downtime. Means some manual person will be pointing the service to the secondary site, right? So the acceptable downtime is coming over here in the high availability, whereas in the fault tolerance, all the systems, I mean the primary and the secondary, both the sites will be active so that even if primary site or the secondary site goes down, the request incoming request will be continuously served regardless of the disruption. So yeah, this is an important factor, as I already mentioned, while measuring the resilience of your system. And coming to the resilience testing in the real ground, um, we, the testers, follow a set of guidelines and a method to prove the resilience of the infrastructure. So, under the high availability, we are covering multiple testings like disaster recovery testing. In this, primary and the secondary site will be there, and primary, once primary goes down, we will verify the secondary is invoked. That is the recovery site is being called, and it is serving the incoming request.
1, 2, 3.
Yep. Hello.
Hello.
Okay.
Please continue. I think we are good.
Yeah, sure. So where we will measure whether the secondary site, that is recovery site, is serving the incoming request while the primary goes down, and vice versa. Similarly, we are having failover and failback testing, in which we are having intersite and intrasite failover and failback. Kubernetes. Okay. Nowadays, many of us are aware that all the on-premise applications are being migrated to the cloud environment. Most of the applications will be hosted like a microservice, right? When it comes with a microservice, then obviously Kubernetes is the best choice for that. Kubernetes, we know that Kubernetes provides us multiple benefits while deploying the applications, and the scaling up and scaling down is very easy with Kubernetes. But deploying the application into the Kubernetes doesn't mean that your applications will be highly available and your system is better resilient. You have to configure the applications in a such a way that it is highly available. So it will be identified when we test the Kubernetes pod components or the node components, and even the microservice resilience. We will induce the latency and check what will the outcome due to that latency and IAC resilience. So these are the some of the testings we are offering to test the resilience of the infrastructure or the underlying services. Yeah.
So let's go on to the traditional testing approach that we used to follow for like a resiliency testing, as well as, and we are going to see the limitations as well. Before proceeding, right? So we used to, like, before proceeding any test scenarios, what we used to do. So we used to understand the environment and your application, and then you have to come up with your test scenarios or test cases that you're planning to include. It may be chaos experiments or whatever it may be. So you should come up with the scenarios based on the thing that you have, and then you have to identify the best tool to execute those. And then like once everything is done, you have to get it agreed or sign off with your respective stakeholders, right? So for each and every infrastructure, you'll be having n number of teams, right? So for each, to test a resiliency in your environment, so you should be having respective teams for each and every test cases, right? So you may depends on may DB team may require, and then in front team would be require, and then project team, as well as your middleware or so and so team would be involved, right? So you have to present that whatever the test scenarios that you have planned, and get it signed off from the team, like whether it could be fine to proceed with that. Then later you will get your availability slot, right? So to proceed with the test execution, because there could be n number of steps to verify the resiliency, right? So to go through one and each and every steps, like you'll be depending on each and every team. There could be a case that where DB has to be go down, and then your server has to be go down, and then middleware has to support us to check certain verification, and then certain services has to be bring down, right? So in that case, you will be depending on their team's support to bring it down, and then you have to manually verify those things, right? So once everything has been done, later on only you can proceed your execution. um, and then followed by once your execution is done, you will be doing your analysis, and then in that you will find out like whether the system performs well, or is there any flaws happened, or it takes more time to bring it back the actual services. There are so many things has to be checked, and then during the analysis, if you found any bottlenecks, then that has to be reported to the respective team, and then the respective analysis has to be happened from their end, and also they have to provide their fixes. Then again we have to re-execute it based on the availability, and then final it will be a result phase where you have to provide all your test results along with your recommendation, right? There could be a huge amount of process involved here. It could be like the major thing here is a coordination and then dependency of the people, right? So by considering this, you can see right, there could be a huge amount of limitation, like since you are depending on the other teams as well, like infra team, DB, as well as your um, project team, or dev, and then other teams, right? So you have to like if someone is not available during in any of the phases, right? So in that case, whatever the activities that you have performed on the execution will go in vain, right? So you cannot perform it at that time. So what you need to do is like you have to get the alternate slot again from each and every one, and then you have to plan, right? Then in that case your delivery may be effective, right? So you cannot complete your test execution on time. So that is the one case. And then like since you are depending on each and every resources, the amount of cost that we are spending on each resource will be very high, right? So to avoid these things, we are planning to provide a new approach that we decided, right? So will help us in avoiding this like a manual intervention, and then coordination stuff, and then dependency of all other teams, and then the cost that we are spending for resources, as well as on the experiment solution, right? To perform a chaos experiment or something. So to avoid these things, we are providing you the a new approach, so that will help us in overcoming these limitations. So we'll see that in the next slide.
So everything is moving forward. Why not our way of testing? So we saw the limitations, right? Which seems to be quite unpleasant. It is creating uh, more dependency on others, and it is entirely blocking our deliverables and consuming more time. So is it possible to overcome those limitations in a modernized way using some automated tools? Yes, it is possible. We have to replace the manual efforts with the automated testing tool of chaos engineering. So, variety of chaos engineering tools are available in the market as licensed and then freeware. What we need to do is just we need to install it on our environment and just it is like config level tuning only has to be done on your environment. Once you've done it right, you can perform the variety of chaos experiments the tool is offering, and also you can create your own experiment and perform it on your environment and see how the system is behaving to that to such chaos scenarios, right? So the strategy basically is like we are intentionally inducing the failures into the system to see how it's behaving or reacting to the scenarios. So that is the main strategy over here. And Now coming to the demo, for the demo purpose, I plan to cover two things. One is high availability, and another one is fault tolerance and the Kubernetes environment. Okay, I'll go to the demo section. So, can you able to see my screen? Actually, let us understand the demo architecture first, how it's running. I have installed Kubernetes on my VMs, and I have formed a clusters which is having the master node and then master VM and then node VM, which is forming a Kubernetes cluster basically. And I have installed the Chaos toolkit for the Kubernetes on my Kubernetes cluster, and some of the applications are running on my Node VM. Say for an example, hotel, and then guest book, some front end application which will receive guest up names in that application, right? So some kind of applications are running basically on my Node VM, and I'm going to trigger experiments on the applications that is to prove two things. First, I said high availability, and second one is fault tolerance, right? After triggering that, we are going to see how we can generate the reports and see how the chaos experiment went, basically. Yeah. So for that, I have already told you people that uh, the demo architecture. So let us see in detail. I'm going to enter into my virtual environment. I've already installed the Kubernetes cluster, Chaos Toolkit for Kubernetes. I'm just entering into my virtual environment to perform the task because this and the one thing, right, the Chaos Toolkit is the tool I'm going to use for doing my chaos experiment, and this is basically a Python based application. So we need to enter into this virtual environment to perform our tasks. Let me show you. So I have a few experiments configured on this environment. Let me show you one thing. Before that, we will see what are all the applications that is running on my Kubernetes cluster. By entering the kubectl command, we can able to see the applications that is running on my machine. Yeah. So yeah, here we go. You can see, right? I already told I have installed our hotel application. which is nothing but one pod is running this ODL application, and three front end application for my guest book. Okay, here we are going to prove two things. One is high availability, and the next one is fault tolerance. We will see what will how the manifest will look like for the high availability. Yeah, to prove that. So if you can see, I'm going to use this experiment, this manifest for my hotel application. Okay, which is going to it will have its prob described. Okay, that will check the steady state of the system, whether it is existing or not. So that kind of check it will do, and what will be the app? It will identify the application based on the label selector, that is the hotel. Okay, the namespace, everything, and we are going to terminate this pod. As I already mentioned, we are going to prove high availability. Once we terminate the pod, it will take some time to create that pod, right? During that time, if you try to access that application, it will not be accessible, because it will be having some acceptable downtime. Here I have mentioned that downtime as 10 seconds in my manifest. Okay, now I'm going to run the pod. Before that, you can see when this pod was created. It was created some 3 hours and 27 minutes ago. I'm going to run the 10 run this experiment. Yeah, so I'm running this experiment. Now you are saying that looks valid, and then what it is checking, it is the the experiment name is what happens if I terminate the pod, and the steady state, it is checking whatever we have given, and state hypothesis pod exists, and probe is nothing but that will validate your system against the conditions we are providing, and here it is executing the action. The pod is terminated, and again it is validating, right? Again it's validating its steady state hypothesis, and then prop check and all it is doing. If I try to open my application again, we can see that hotel application, it got created 40 seconds ago. Okay, so it got terminated, and it got recreated. So here what we are proving is high availability. The it will be down for some time, and then again it is coming up. Even if we destroy the application, even if something is happening to your application, it is coming up. So we could able to prove that high availability of this application using this experiment, chaos experiment, using the chaos toolkit. Yeah, again, as I said, I'm going to validate my fault tolerance. Fault tolerance, in the sense, it should not take any downtime. It should be continuously operable, correct? So for that, I am going to start an application inside my cluster. It is not exposed to the external world yet. I'm just using the node port to start this application. So it started listening. Let me open a new session in parallel. Okay. Uh, we will try to execute the fault tolerance now. Let it comes up. Meanwhile, yeah, okay. So let us have a look at the fault tolerance file manifest. Yeah. So I have defined my manifest here in this. Okay, here it is not there. But okay, here it is. http.yaml is my manifest for this fault tolerance one. Let me run. I will explain you how the manifest was I mean, how the experiment I have configured. So in this case, what we are going to check is application, whether the application is healthy or not. How we are going to check is, we are going to check by sending the HTTP request to this local host colon 8080 on which my front end application is listening. That is nothing but my guestbook application, right? So tolerance is described as 200. So in return, we need to get the 200 as the status code, right? And the type is HTTP. After that, what we are going to do is we are going to terminate the pod. So as per fault tolerance, our application has to get access even if it get terminated, right? We are going to send request and we are going to terminate the pod, and we'll again send the request and we will validate whether our request is being served and it is available. Yeah, I'm going to run this experiment. For this running, right, I'm going to parallelly create a report. That's why I'm using hyphen journal path hyphen file name for the output of this output of this experiment. So what is the unexpected? Okay, I'm sorry. Let's see. So if you can see, right, it is confirming the steady state hypothesis that the app is healthy, and it is sending the request to the pod and it is getting the response to the request, and the steady state hypothesis is met now, and we are going to run the action that is terminate pod. Here it is terminating the pod. Meanwhile, again after terminating the pod, it is checking again the app is healthy or not by sending the HTTP request to the local host. Again, it is checking the app is healthy or not. That is whether it is responding to that request, and then whether the steady state hypothesis is met or not, right? So if I again access my applications, right? Let me access my applications. You can see even if the pod is terminated, we know that if a pod is terminated, we cannot access that application, correct? But we have the replica set that is defined as 3 in this deployment file.
Excuse me, ma'am. Yeah, we just have 5 minutes left.
Okay, fine. Yeah. Yeah, sure. So here you can see, right? It is within the 65 seconds. It's then again the new pod is running. Okay, let us just create the report of this experiment, and then we'll see. I'm going to run the Docker run for this. Let me execute, and we'll see. Yeah. So here my report .pdf got generated for that executed uh, fault tolerant experiment. We will try to open that experiment report and we'll see. Okay, here it is. I'm going to export it via the FileZilla. Yeah, let me open it. So if I open this report, you can see the report completely. So before execution and after the execution, it is responding, and we also terminated the pod. After the termination, it is again the steady state hypothesis is met and it is running as expected. So the concept we are trying to explain is that with the chaos testing tool, we can able to run the experiments without the support from the dependent teams. Yeah, and also here we are minimizing the efforts, cost efforts, and also we are able to achieve our deliverables in a faster manner.
So let's come to the benefits and then the best practices section, right? So when it comes to benefits, as Hema mentioned, right? So dependency has been sorted out, and then cost wise also we are having benefits. So as we are having own control over the chaos experiments and then the environments, so we can execute our own test and then deliver it on time. So since we are configuring by using our manifest, right? So we are just configuring our scenarios like chaos experiment in that manifest, and then we are directly executing it. So that is very simple, and then we can try to execute it in a easy manner. And then like observability. So when it comes to observability, this is for monitoring purpose. We have our telegraph solution, like our open source solution we have developed, and then so by using that we can achieve observability as well. So we can view that result in a very like for real time monitoring, we can use that telegraph grafana based integration to achieve the observability. So these are all the benefits by using our solution. And then the best practices that we need to follow is we need to choose the chaos experiment tool that suits our needs, actually, like depends on the environment or the cloud solution that we have. What are the types of testing that we need to do? So based on that, we need to identify our tool that we need to execute. And then you should have your best remedy, right? So for all the real time resilience, you should prepare what kind of solution that we need to apply for all the failure condition that you should know. And the best practice that we need to follow is you should always go with a lower environment which is similar to production, like to experiment those chaos scenarios. It's always good to go with a lower environment, and then you can prove it, and then later you can apply it when required for production. And then people nowadays adopting a cost effective solution, that is infrastructure as a code, right? So these are all the best practices that we can follow when it comes to resiliency testing.
Yeah.
So thank you so much. Let's go on to Q&A.
Yeah. Any questions?
Guys, if you have any questions, just feel free to ask or maybe drop a message in the chat box. So any question appearing, but I would like to thank you both for the wonderful session and the demo that you have shown to us. And Alankrit, can you bring up the slide as well?
Yes, sir. Yes, sir.
Yes, so thank you so much, Mohanpriya and Hema. It was a wonderful time with both of you all. I would.